Okay, so this is 11.3, and we're still solving systems. And remember, solving systems is finding the point at which two lines cross. So we're doing it what they call symbolically. We aren't graphing them. But don't forget that if you did graph these, it would be the point at which they intersect. Okay, so we've done solving them graphically, which is just graphing them on a graph and then finding where they cross. We've done solving them symbolically by using substitution, and that was what you just did in 11.2. 11.3 is just another way. The reason why they have different ways is different problems will be easier with different methods. Okay, so this method is called elimination, and it's called elimination, but it also has substitution in it. And so that's why it comes after the substitution. So elimination, if you think about the word eliminate, eliminate means you're going to take it out. And so what you're doing, what you're trying to do with these is you're trying to eliminate a variable. Because you can't, it's hard to solve anything with two variables, but you know that the two lines cross and they have the one point that they share, so you're able to manipulate it and get rid of that one variable, just like we did with substitution. Okay, so here's two equations. And elimination is all about using adding and subtracting, and you can also use multiplication to solve it. And so if I look at these two equations and I think about adding them together, if I add these together and I add them vertically, so I add them going down, okay, x plus 5x is going to give me 6x. Whoops. That's going to give me 6x. And then remember that this is a negative 2y. Remember that sign goes with it. So if I add a negative 2y and a positive 2y, or you can call it minus 2y and plus 2y, they're going to eliminate and be 0. Okay? And 0y, I don't even need to write it. If you don't have any y's, you don't have any y's. So there's no sense in writing 0y. So this is why it's called elimination. So I just eliminated all the y's just by adding these two equations together. And then I can keep adding. Don't forget you got to add this side too, because we want to make sure that we complete the equation. So negative 19 plus 1 is negative 18. Now if I look at the equation that I have now, I can solve for x by dividing by 6, so I get x equals negative 3. And now that I have x, how do you think I'm going to get y? Well, I'm going to substitute it back in. So that's why I said it also has substitution in it. So now that I used elimination to get my x, I know that my two coordinates, or my one coordinate, is going to be negative 3 for the x, but I got to figure out what it's going to be for the y. So I can substitute it into either equation. So it doesn't matter which one you choose. I'm going to go ahead and choose this one. But again, it doesn't matter. So I'm going to take that equation, which was x minus 2y equals negative 19. And instead of the x, I'm going to put a negative 3 in there. And I'm going to solve it. So I'm going to add 3 to both sides. I'm going to bring down the negative 2y. Make sure you bring down that negative with it. 16, negative 16. Is that right? 17, 18, 19. Yeah. Negative 16. Divide by negative 2. And I get y equals 8. So then I know that the second, the y value is 8. So if I graphed it, these two lines would crisscross in one point. So they have one solution at negative 3, 8. Okay, so I can double check it, and I'm going to erase some of this just to give me room. Okay, but remember, you can always double check these and know if you're right or wrong. You don't have to wonder, or you don't have to try to search in the textbook to see if they have an answer. I can take the original equations, so I'll take this top one, and the top one was x minus 2y equals negative 19, and I can replace the x and y with what I think it is, negative 3 and 8. So negative 3 minus 2 times 8 equals negative 19. So all I did was I replaced the x and the y with my x and y. Okay, so now I'm going to solve it and make sure it makes a true statement. So negative 3 minus 16 equals negative 19. Negative 3 minus 16 is negative 19. So then I know that that point definitely lies on that top equation line. So if I graphed this top equation, this point negative 3, 8 will lie on it. That doesn't guarantee me that's where they both cross. So I've got to make sure that it's also true for this one. So 5x plus 2y equals 1. So I'm going to replace the x and the y again. My dog is pounding on the wall. Okay, and negative 15 plus 16, and that one is also true. And so then I know that I'm right. Okay, so you can pause it and try this one, and then come back and see if you got it. Okay, so I'm going to add these two equations, and 3x plus 1x equals 4x. Negative 4y and positive 4y, those are going to eliminate. 10 minus 2 is 8. I can divide by 4. I get x equals 2. So I know that 2 is one of my answers. Now I can substitute back in. I think I'm going to substitute into this one this time. 2 plus 4y equals negative 2. And I get, whoops, did I do something wrong? I got 2 and 2. So, oh, yes, I did something wrong. I was like, wait a minute, it doesn't cross at 0. This should have been a minus. Minus 2y. So 4, or minus 2. 4y and negative 2 take away 2 is negative 4. There we go. Divide by 4. That looks better. Y equals negative 1. So then I know this is negative 1. And again, I can go and plug it in and make sure. I won't do it because it's making the video longer, and I'm sure you don't have enough time to watch all that. But I did show you can do it, and it's a good idea to do it to make sure. Okay, so not all equations are going to line up perfectly for you to add them. And remember at the beginning I said sometimes you use subtraction. So if you take a look at these two, if I add, those are not going to line up. I mean, if I add, I'm going to get 4x and I'm going to get minus 4y and nothing eliminated, and then whatever. Okay, so I don't want to use addition. I want to use subtraction. But the thing that you need to remember is that you're subtracting everything in this equation. So usually what I do, because I will forget, like if I'm subtracting the 2x minus the 2x, I'll remember that and go, oh yeah, it eliminates. And then I'll get to here and I'll go y minus 5y. Well, that's not true. That's not really what's happening. It's y take away negative 5y. Which I know for me, I'll forget to look out there. My own kid always leaves it out there and remembers, but for me that's dangerous. I will forget. So what I do is I stick with addition, but I change all these signs. So I change everything that was a positive, I change to a negative. Everything that was a negative, I change to a positive. The reason that works, two ways you can think about it. You can think about me multiplying everything by negative 1, and you know that with an equation, as long as you do, if you can multiply anything you want, as long as you do it all the way through. You can also think of it as like when you subtract a negative. If I subtract a negative 5, subtracting a negative 5 is the same as just adding 5. Okay, so for me it's easier to not think of it as subtraction and to always add and just change all my signs if I need to. So now 2x minus 2x, that will eliminate, which is what I want because of elimination. And you can see here I get 6y. So if I wouldn't have done that, I would have got a negative 4y and everything would have went wrong. And then on the right hand side, negative 5 plus negative 13, or minus 13, or plus negative 13, however you want to think about it. 5, 6, 7, 8, so I get a negative 18. Divide by 6, I get y equals negative 3. So I got y this time, so I need to remember that that's in the y position. And now I want to plug back in and get x. I'm going to plug it in, or substitute it into the first equation. So 2x plus a negative 3 equals negative 5. So I'm going to add 3. 2x equals negative 2. X equals negative 1. So I get a negative 1. Okay, so I'll give you one to try. Okay, so give that one a try. And pause it, and then you can come back. So you're eliminating the y's. Okay, so I'm eliminating the y's, but I can see that they're not going to eliminate if I just leave it alone, because they're both adding by 4. So I'm going to add, and I'm going to just change all the signs. One of the things you want to watch for on changing the signs is that you remember to change the right-hand side. That's what I've seen in classes consistently, is the students will change the left-hand side and forget on the right-hand side, like the minus 8, like the negative 8. Okay, so 3x plus 2x makes 5x. Eliminate. And 10. These become really easy as soon as you do. They're long at first, and so it's always like, oh gosh, I don't want to do these. They take so long. But as soon as you do like the first 5, it all kicks in. They become really easy and really quick. I'm going to plug back in. I'm going to go ahead and do it to the top equation, but again, remember, it doesn't matter. So I get the 0.23. So on this next one, you're going to see that nothing really eliminates real nicely. If you look at the x's, they're different. One's a 2, one's a negative 1. If you look at the y's, they're different. One's a 1, one's a 3. And so if I add or subtract, it doesn't matter. Nothing's going to eliminate. And so we need to figure out a way to eliminate, a way to change these so that things do eliminate. And you can choose the x or the y. Okay, it does not matter which variable you choose. I just usually choose whichever one looks easier to manipulate. So I'm going to go ahead and choose the x's. Okay, so if I look at the x's, it would be really nice if this was a 2 right here, because then it would totally eliminate. So what I'm going to do, remember that you can multiply equations by whatever you want as long as you do it all the way through the equation. And so I'm going to multiply a 2 all the way through this bottom equation, and I'm going to rewrite it. So I'm going to rewrite my whole thing over here. So I still have the top equation, which is 2x plus y equals 3. And I'm going to change the bottom equation by multiplying a 2 throughout the whole equation. So I'm going to get negative 2x plus 6y equals negative 24. And again, a common error that I see in the classroom is that they don't do this last one. Okay, just remember it has to go through everything. So now when I look at the two equations, they're set up really nicely. I can go ahead and go through my adding them and eliminating. The x's eliminate. The y's add up to 7y equals negative 21. Divide by 7. And it's the same old stuff again. I've got the y coordinate. So now I need the x, so I'm going to plug back in. I'm going to go ahead and plug it into the top one. I would suggest not plugging it into the equation that you changed, because if for some reason something went wrong, I don't know, I just would plug it into one of the original ones. So 2x plus negative 3 equals 3. So add 3. X equals 3. So I get 3, negative 3. Okay, so I'll write another one and you can pause it and try it yourself. Okay, so here's two equations. Either eliminate the x's or the y's. Now you can multiply the top equation or you can do the bottom equation. It does not matter which one you affect. Okay, so just choose your x's or y's and go for it. Okay, I'm going to go ahead and choose my x's, but you can choose your y's, and I can do it both ways, I guess. So I'm going to go ahead and multiply everything on top by a positive 3. So I'm going to get 3x plus 6y equals 33. And the bottom equation is going to stay the same. I'm going to add to eliminate. So these are gone. That's 7y, and that's 28. Divide by 7, I get y equals 4. I can plug back in. I'm going to use the top equation to plug back in. So it's, oops, 3, 4. Okay. Sometimes, let me explain what can happen too. Let me rewrite this for a second and talk to you about. Okay, so if I wanted to eliminate the y's, let's say that the y's looked easier. I don't want to multiply a 2 all the way through. I want to multiply a negative 2 all the way through. So be sure that you look to see what you want this y to be. I would like this y to be a negative 2 to eliminate. So because this was a positive y, I want to multiply a negative 2 all the way through. So I was just going to make the point that it doesn't always have to be a positive number that you multiply through. It's whatever you need, whatever you'd like it to be. So what happens if neither equation looks like you can change it like this? Also, sometimes they're not in the same order, and sometimes you need to change them to make sure they're in the same order, and I'll go through those too, just in case I forget. Okay, so when you look at these two equations, neither one of them look like I can change them. If I look at the bottom, if I look at the x's, if I multiply this one by 5, then I'm going to, if this one by 5, I'm going to get 10. So, and if I look at the y's, they don't really match up either. But what I can do is I can multiply both equations so that something matches. So just look at the x's or the y's, and again, it's just whatever you choose. I'm going to choose the x's. I can't change the 2 into a 5 or the 5 into a 2, but what I can do is change them both into a 10. One a negative 10 and one a positive 10. So 10 is 5 and 2 are a factor of 10, and that's how I came up with 10. You can look for the least common multiple, or the greatest common factor. You can look for different products, but you can also just multiply them together. Okay, so I can multiply this top equation by 2, and I can multiply the bottom equation by 5. And I picked positive 2 because I can see that's going to make a negative 10 up on top. And I picked positive 5 because I see it's going to make a positive 10 on bottom. And remember, I want them to match. So if I do that, this is what my new equations look like. Negative 10x plus 4. Remember, it's going all the way through the equation. So plus 4y equals 64. And the bottom equation, I get positive 10x, which is nice. Now I'm going to be able to eliminate, plus 15y equals 50. So now it's set up where I can just use addition and eliminate. Get 19y equals 114, and I could keep going. Okay, so the point, I'm not going to keep going on that. I'll give you another problem that you can practice at. The point is that if you look at the x and y variables and nothing looks like it's going to eliminate, you can multiply them by each other to make them eliminate nicely. So here's one that you can try. Okay, so you might want to pause it and try this one. I will eliminate the x's first, and then I'll reverse it and show you that you could eliminate the y's, and you can use different numbers for that. So you can look for numbers that are smaller. And so go ahead and try the x's to start with. Okay, so I'm going to go ahead and multiply this top one by 5 and the bottom one by 7, but the problem is I need one of those to be a negative. So it doesn't matter which one you make a negative. I'll just go ahead and make the 7 a negative, but you could have made the 5 a negative. I just want one of them to be a negative so that they eliminate. So 5 times 7 is 35x minus, let's see, that's 60. Y equals 110, and that's negative 35x plus 56y equals 98. And now I can eliminate. There's my elimination because one's positive and one's negative. And this will give me negative 4y equals 12, negative 4, y equals negative 3. And I screwed up already. What was I doing? I added those together. Should not do this first thing in the morning. That's 8. 208. There's my other error. Phew, maybe I should just start all over. Let me try this. Sorry about that. I'd start all over, but we're at 23 minutes, and it would take a while to start all over. Okay, so that's negative 12. And divide by negative 4. There we go. Wake up. Okay. So there we go. We have y equals 3. So now we can plug it back in. I'm going to go ahead and plug it into the top equation. Let's see if I can do this right. Um, 10 and divide by 5. Phew. X equals 2. So the answer is 2, 3. The ordered pair is 2, 3. So I chose to eliminate the x's, but there also is an easier way so I'll show you the next one. You don't have to if you don't want to, but it's just a different way. So let me show you how to do that one. Okay, so once you start to get the hang of this, you'll start to discover which variable is easier. And actually this one doesn't look easier at the start, but this is the way I would have done it. I would have noticed that 12 and 8, if I multiply the 12 by 2, I get 24, and if I multiply the 8 by 3, I get 24. And so I can keep the number smaller. You notice on the last equations I screwed up because the number started to get bigger too. So, I mean, you don't have to worry about it too much. You have a calculator, but I'm going to multiply this top one by a positive 2, but I'm going to multiply this bottom one by a negative 3. The reason I'm choosing the negative is because I want this negative 8y to turn into a positive 24y. So 2 and 3 are factors, both factors, common factors of 12 and 8. And so I'm looking for the least common factor between those two. It just keeps the numbers smaller. But again, there's no reason you can't do it like the time we just did it before with the 7 and 5. Okay, so there's lots of different ways to approach these. That's why in the answer keys I'll always put, this is just one way to do it. So I'm going to multiply the 2 all the way through. I'm going to get 14x minus 24y equals negative 44. And on the bottom, when I multiply the 3 through, I'm going to get negative 15x positive 24y. The positive because it's negative 3 times the negative 8. And then a positive, whatever 14 times 3 is, 42. Positive 42. And it's a positive because of negative 3 times the negative 14. So now if I add these two together, these eliminate. I get negative x equals negative 2. So I can divide by negative 1 and I get x equals 2. And the numbers were a lot easier to deal with. And then I can plug the 2 back into one of the equations. I'm going to go ahead and plug it into the bottom one. So 5 times 2 minus 8y equals negative 14. So 10 minus 8y equals negative 14. And I get y equals 3. So I get the same answer. So try these two. Let's go ahead and work on eliminating the x's so that we're doing it the same way. If you want to pause it, then you can pause it. Okay, so I'm going to work on eliminating my x's. So I'm going to go ahead and multiply the top equation by 3 so that I'll have 6x. And I'm going to multiply the bottom equation by positive 2, so I'll have negative 6x because there's already a negative there. So then my equations will be 6x plus 15y equals, let's see, 18, 678. And negative 6x minus 8y equals negative 50. Okay, I'm going to add those two. Eliminate the x's. I'm going to get 7y, right, 7 times 4, yeah, equals 28. Divide by 7, and I get y equals 4. And then I can plug it into one of the original equations. I'm going to use the top one. And I get 2x equals 6, and x equals 3. So I have the ordered pair, 3, 4. Okay, so not all the equations are going to be set up nicely for you so that the x's are on top of each other and the y's are on top of each other, and you just have to alter them a little bit, and I'll find one similar to that. Also, with all of these, we've come out with one answer. Remember, there can be no solutions and infinitely many, so maybe I'll pick one of those. So here's one that's not set up all stacked, the x is on top, y is on top. So what you want to do is alter one of the equations so that they are in the same order. I'm going to go ahead, and it doesn't matter which one you alter, I'm going to go ahead and solve this one for y so that it looks like this top one. Okay, so if I take the 4 plus y equals negative x, and I move the 4 over, I'm going to get y equals, and I want my x first because that's how it is in the first equation, negative x minus 4. So I'm going to rewrite my two equations here. So I have y equals negative x plus 5, and I have y equals negative x minus 4. So now I can stack them and use elimination. Well, you can see that nothing eliminates right now. If I added them the way they are, I would get 2y here, and I would get negative 2x and a 1. So I don't want all that. So I'm going to take this equation, I'm going to take one of the equations and multiply a negative 1 through it. Okay, so now my new equations are negative y equals x minus 5. And my other equation was y equals negative x minus 4. So I can see that this is going to eliminate, and this is going to eliminate too, which means that I'm going to have a 0 on the left. And if I had a 0 on the right, it would be infinitely many. That means that the two lines would be on top of each other. I would have an infinite number of solutions. But since it's not 0 equals 0, since it's 0 equals negative 9, that's not a true statement. And so that's no solution. One thing that I find that the students get confused on is if you go and you solve and you get 0 equals 0, they want to say no solution because it's a 0. If you get 0 equals 0 or 5 equals 5 or 10 equals 10, that means that these are infinitely many. There's two different solutions. There's infinitely many and there's no solutions. Well, there's three and there's one solution. And so you want to know the difference between those. And I didn't do a lot in the video, but they come up in the homework. So if you need more of those type, let me know. Okay, but they will come up on the test too. The only thing that I'm trying to think what I haven't covered is story problems. And so definitely those will be on the final, so we want to cover those. We have them in the homework and we have them on the worksheet, or not, they aren't on the worksheet I don't think, but they're in the homework and they're on the quiz. So here's a story problem. If I have a math test and it has, 25 problems on it. Some of the problems are 2 points, and some of them are 3-point problems. The test is worth 60 points total. Oops. If I asked how many 2-point problems are there on the test and how many 3-point problems are there on the test, and that's a systems of equation. Can you write two equations and then solve them through a system? Okay, so the first equation you want to get from the math test having 25 problems. Okay, and since there's 2-point problems and 3-point problems, we can say X is the 2-point problems and Y's are the 3-point problems. So the number of 2-point problems plus the number of 3-point problems has to equal 25 problems. And then you know that the test is worth 60 points. So however many, this is the number of 2-point problems. However many 2-point problems there are, the other equation can come from knowing that it's 60 points total. So since X is the number of 2-point problems, if I want to know how many points you got off of that, it would be 2 times X. Okay? And then for the Y, that would be 3 times Y. And that has to equal 60 points. So now you have the system of equations. Sometimes we'll let you choose whatever format you want, and sometimes they'll say you have to use substitution or you have to use elimination. Since we're in the elimination, let's say we have to use elimination. So you could pause it and try your elimination. All right, so I'm going to go ahead and multiply this one by -2 all the way through, and I'm going to choose to eliminate the x's. So I'm going to get -2x minus 2y equals -50, and the bottom equation was 2x plus 3y, and I'm leaving that one alone. I can see that these are eliminating nicely. I have y equals 10. And so that means there must be 10 3-point problems. Well, if there's 10 3-point problems and there's 25 altogether, I can think about plugging it into there. So there must be 10 3-point problems, and there must be 15 2-point problems. That's about it for 11.2 or 11.3, but make sure you solve them using the elimination. Again, on the final they're telling me they will specifically ask you to solve them a certain way, and if you choose to solve it the other way, they take quite a few points off of that. So the textbook assignments will give you some good practice at story problems, and then the worksheet that I gave you will just give you repeated practice at just having the two equations and solving through elimination.